Alright, so hi guys. So in this video, what we're going to focus on is complex numbers, right? Now, these are very important when it comes to calculus. That is because in calculus, although we don't really work a lot with complex numbers in calculus, but we do, it is something very important to know, because in calculus, especially when you're solving for the, when you're finding the critical points of a function, and when you're finding the absolute minimum and maximum, or the extrema of a function, knowing that it has an imaginary, we have to know how to solve equations where you have imaginary numbers. We also have to know the relationships of imaginary numbers, because of course it's something very useful to know, right? I mean, as a student, some people would think, well, you know, if a quadratic has an imaginary, what does that mean? Where do imaginaries come from? You know, because there's a whole explanation about a complex number and an imaginary number. So that's what this section is about, and it's very important to know that for calculus, because that way we can actually know, well, what's the definition of an imaginary number, right? And where does that come from? Although it doesn't have a lot to do with, you know, with calculus in and of itself, like we don't really work a lot with imaginaries, at least I don't think in Cal 1 and 2, but it's very useful to know, because at least we know the relationship that those have with any equation that we come across, right? So a complex number is any number of the form a plus bi. We know this, we learned this in college algebra. And this is where a and b are real numbers, and I squared equals -1. The real part of this complex number is a, and the imaginary part is b. The two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. So what does that mean, basically? So basically, and let me actually... six, okay. So, you may wonder, like, what does that mean? Right? And, so basically, this is something very important to remember, because, like I said, although we don't really work a lot with these in calculus, it's very useful to know at least the relationship as numbers, like where do imaginaries come from and stuff like that. So an imaginary number, any imaginary number, or actually, hold on, any complex number is of the form a plus bi, where so let's see here. Where a, so basically, where a and b are real numbers and I squared equals -1, the real part, so it says that the real part of this imaginary number, so basically if we have something like 3, this is a real number, right? This can be rewritten as 3 plus 0i, right? And it's a real number because 3 is a real number, right? A equals 3 and b equals 0, right? That's how we know that a is the real number and b is the imaginary number, because it has an I next to it, right? Now, So here are examples. So 3 plus 4i, the real part is 3 and the imaginary part is 4. 1/2 minus 2/3 I. The real part is 1/2, the imaginary part is negative 2/3. And here we have a 6i, but also this is also a complex number because, you know, a complex number doesn't have to be a number that has I necessarily, right? The real part is 0 because we have a 0 plus 6i and the imaginary part is 6. And here, the real part is for negative 7, the real part is negative 7, and the imaginary part is 0 because bi is negative 7 plus 0i. That means that the imaginary number is 0, right? So, let's see here. So obviously, if we do, for example, so if we do x squared equals negative 4, for example, this is where imaginaries play a huge role in solutions to polynomials, right? So if we have x squared equals negative 4, we take the square root of both sides, and remember that the square root of negative 1 equals I, so we have x equals, and we have to put plus or minus, and we have the square root of negative 1 times the square root of 4. That would be x equals plus or minus I, and the square root of 4 is 2, so it's going to be times 2. So the solution would be plus or minus 2i. And we can plug that back in to x squared equals 4. We can verify that that's true by plugging it back in. So we would say 2i quantity squared equals 4. So we can say 2i times 2i, that's basically 2 times 2 times I, which is 4i squared, right? And 4i squared is 4 times negative 1, which is negative 4. So you see how it equals this number here. So basically x squared equals negative 4. When we say, or rather when we say x squared equals 4. So, and it's similar in the way that that we go ahead and we so let's see here. Sorry, I meant to say negative 4, not 4. But yes, here you see how if we get 4i squared, we get 4 times negative 1, which is negative 4, and it's exactly what we have right here. And then similarly, if we do, so because, and if we do plus, or if we do the negative term, negative 2i quantity squared, will that equal negative 4? Well, let's check. We have negative 2 times negative 2 times I, right? That's negative. Is that equal to negative 4? We say 4 times I squared equals negative 4. We know that I squared is just the square root of negative 1 quantity squared, which is negative 1. So we have 4 times negative 1 equals negative 4. So negative 4 equals negative 4. So we verified it, right? Okay. So that's what that's saying, right? That's what that's saying. And we know that, so obviously this is another part, multiplying, subtracting, adding, and adding complex numbers, right? This is the definition. A plus bi plus c plus di equals a plus c plus b plus d times I, right? And similarly for subtraction. You don't have to know, I mean, I wouldn't try to overthink this so much, right? These are, yes, these are our definitions, and it's just to explain why we do it this way. Why, like, basically, why do we add it this way? Why do we multiply it this way, etc., right? But you don't have to, like, memorize these properties unless you are wanting to prove exactly why they're like that. but in a lot of high school math classes, and and even in college, if you're not a math major, that is, you don't have to prove why these are true, right? You would do that in proofs, which is a whole other class. For example, 3, so let's look at this one here. And I can try to copy it and see if it actually copies. So, okay, never mind. Okay, so we have 3 plus 5i plus 4 minus 2i, right? So all we have to do is combine like terms. This is like, think of this as like algebraic expressions, right? We have a 3, and then we have a plus 4, and then we have a 5 plus 5i, and then we have a minus 2i. This positive number, in reality, we can take out the parentheses here because it's a positive number. It's okay. It's like saying 2x minus 6 plus 3x minus 1. It's okay to say that this is 2x minus 6 plus 3x minus 1. That's all this is, really. And it's very easy. You say 7 plus 3i. Now you want to make sure you put the real number first and then the I term second, or the number with the I term second. You don't want to say 3i plus 7 because I would think that the professor would mark it wrong because it has to be of the form a plus bi, right? So that's how you add. That's how you add an imaginary number, right? Now, with subtraction, it's a little different. Subtraction, it's kind of the same as with algebraic expressions, but except it's just with an imaginary number, right? So it's okay to look at this as an algebraic expression. So you can say 3 plus 5i, and then distribute your negative, and you say minus 4 plus 2i, right? This is 3 minus 4 plus 5i plus 2i, right? Negative 1 plus 7i would be your answer. And this is of the form a plus bi. That's how you do it. You never want to say 7i minus 1 because the professor might mark it wrong, right? And then there's multiplication. 3 plus 5i. And this is a very fast review, guys, but that's because we went over this in college algebra. So when you do this, you say 3 times 4, that's 12, minus 6i plus 20i, and then minus 10i squared. Now remember, I squared is negative 1, so you're going to say 12, and then negative 6 plus 20i, or negative 6i plus 20i, that's 14i. And then I squared is negative 1, so you're going to say minus 10 times negative 1. So it's going to be 12 plus 10, because this is 10, right? Plus 14i. So that you're going to say 22 plus 14i. And this would be your answer, right? So yes, as you can see, I mean, they used these properties, but again, you don't have to do that if you really don't want to do that. Like, basically how they did it, they went ahead and said that it was so like for the addition one, they said that this is just 3 plus 4 plus I times 5 minus 2, really. And then they say that this is 7 plus I times 5 minus 2, that's 3, so it's going to be 7 plus 3I. That's how they did it, but again, you don't have to do that if you don't want to. If that helps, you can go ahead and do it. But I always like to just combine my fractions, or my variables, right? Now, D is interesting. Part D says I to the 23rd power. Now remember that if you have I squared, that's negative 1. If you have I cubed, that's negative I. So you want to make sure you remember both of these, right? So I to the 23rd, you can rewrite this as I to the, let's see, we can say I to the 10th, and then to the 2nd power, and then times I cubed. And we can do this, and we can say, well, this is really I squared to the 5th, basically this one here is I squared to the 5th, and then when we say to the 2nd, we're going to go ahead and put that in to the 2nd power, right? And then we can say I squared times I, right? So then we have I squared to the 5th to the 2nd power times negative 1 times I. So then we have, and I squared is negative 1, so we have negative 1 to the 5th quantity squared, right? Because in reality, this I squared is negative 1, and then we raise it to the 5th power, and then to the 2nd power. So negative 1 to the 5th, that's just, when it's an odd number, it's going to be the negative number, negative 1, and we have quantity squared, and then times negative I, right? Because this is negative I. So then we have 1 times negative I, so this is negative I, right? So that's how that works. And as you can see, yes, they got negative I. It doesn't matter how you do it, but that's one way to do it. If that's usually how I do it, but you can do it any way you want. This is how they did it. They just said this is I to the 22 plus 1, so then they said, oh, it's I squared to the 11th times I, and then they said negative 1 to the 11th times I. That's just, so negative 1 to the 11th is negative 1, and then times I, so then they said negative I, right? Okay. So it says division of complex numbers is like rationalizing the denominator of a radical expression. That's very true. So anytime you have like a plus bi over c plus di, you usually multiply by the conjugate of the denominator, that is c minus di, and you get something like this, right? So then we want to do these in of the form a plus bi. So if we look at part A, it tells us 3 plus 5i over 1 minus 2i, right? This will be, we're going to multiply by the conjugate of the bottom. That's like if I had 1 over 1 minus square root 3. So then I say, oh, this is 1 over 1 plus square root 3. So what am I going to say over here? Well, it's going to be times 1 plus 2i over 1 plus 2i. So then this is going to give me 3 plus 5i times 1 plus 2i over, and then we can use the sum of two, or the sum and difference pattern that says a plus b times a minus b equals a squared minus b squared. However, you have to be careful because you have, so it's 1 squared, right? And then you're going to say minus the quantity 2i quantity squared. This is equal to, and we can do the top. So basically we have 3, so FOIL method, 3 plus 6i, and then plus 5i plus 10i squared, right? Over, and then we have 1 squared, that's 1, and then 2i quantity squared, that's really just 2 squared times I squared, which is 4i squared, which is equal to 4 times square root of negative 1 quantity squared, which is 4 times negative 1, which is negative 4. So then we have minus negative 4, right? Let me color code that very quickly. So this is what I'm saying, basically. Right, so that's how you would do it. And then you have, so this is going to be 3, and then we have plus 6i plus 5i, so it's 3 plus 11i, and then plus 10i squared, that's just 10 times negative 1, over 1 plus 4. So then we have 3 minus 10 plus 11i over 5. So then we have negative 7 plus 11i over 5, right? Okay. Now one more thing to notice, and this is where I feel like some people get very confused when it comes to writing this as a sum of two different fractions. Anytime I have a plus b over c, this is a over c plus b over c, right? So then I can say this is equal to negative 7 over 5 plus 11i, or I can say 11/5 I, right? Or you can also say negative 7 over 5 plus 11i over 5. That can also work. One thing I want to quickly mention, 11, or anytime I have 11x over 5, this is not the same thing as 11 over 5x, okay? So yes, as you can see, that's what they got for this one. And we can do this one as well. So usually, so this one is 7 plus 3i over 4i. Now, you can write it, if you really don't know whether or not, or what the conjugate of 4i is, you can do the following. This is equal to 7 plus 3i over 0 plus 4i. So then you can say, oh, I can multiply by the conjugate, which is 0 minus 4i over 0 minus 4i, right? This equals to 7 plus 3i times negative 4i over, and I can say 4i times negative 4i, right? So then I can say this is negative 4i times 7 plus 3i over, and I can say this is, so 4i times negative 4i, that's 4 times negative 4 times I squared, which is equal to, and then I can use distributive property. I can say this is negative 28i plus, or actually, negative 28i minus 12i over, and then I can say 4 times negative 4, that's negative 16. I squared is just negative 1, and I can say that this is equal to negative 40i over 16, and I can simplify this fraction by saying that negative 40i is really just, so it's going to be negative 4 times 10i over 4 times 4. This cancels out, so I get negative 10i over 4. I can simplify that one more time, so I can say negative 2 times 5i over 2 times 2. This cancels out, so then my answer, and remember to include the negative, because it's just the positive 2 that cancels out. So I can say that this is, and there's a times symbol, so I can say negative 5i over 2, right? Let me see something really quick, hold on. So 7 plus 3i over 4i. I feel like I did something wrong here. Negative 28i minus 12. Oh, 12i squared. My bad. That's what I did wrong. Oops. Sorry, guys. 12i squared minus 12i squared. So it's negative 28i minus 12 times negative 1 over 16. So then this is going to be equal to negative 28i plus 12 over 16. This is the same as saying 12 minus 28i over 16. Then we do, we factor out, we can factor out a 4 from this, right? 4 times 3 minus 7i over 4 times 4, right? So then we have 3 minus 7i all over 4, which is equal to 3/4 minus 7/4 I, or 3/4 minus 7i over 4. Right? Those are 3 possible answers, except they always want to make sure that you write it. Preferably, they want me to write it in this form. In this form here. And that was an accident. I didn't mean to cross that out. In this form, right? Or in this form, but preferably this one here. This form is the most preferable one that they would give you as an answer choice, right? Okay, so square roots of negative numbers, yes. Anytime you have a negative number inside the square root, you always want to make sure to take that negative square root out. So you can do the following. So basically, let's do this one here, right? Let's do example 5. Or let's do one of these examples. So anytime I have a negative square root inside the radical, or a negative inside the radical, if I say, for example, the square root of a negative, I'm trying to think. The square root of negative 124, for example. Well, I can say this is plus or minus I times the square root of 124. You always want to include plus or minus. And that is because anytime you have, so basically, anytime you have the square root of x, that's always equal to plus or minus x, because x, square root of x squared is x, and square root of negative x quantity squared is also x. And usually the reason why they say that the square root of x squared equals the absolute value of x, that is because the absolute value of x is equal to x or negative x, right? Anyways, this one is, so with this one, you're going to want to simplify this square root, right? So you have 124 as your square root. Well, this is equal to, and you can remember one way to do this is you can list all your squares, right? 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. I would always go down to 10, right? And then 10 squared is 100. Okay, so looking at this, I can do the factor tree. I can say, for example, 4 and 31. And if you don't know if it's divisible by something, you can always just try to divide it out. So like 124 divided by 4, and then you multiply 3. You subtract 12, and then you get 4 as your answer. 4 divided by 4 is just 1. So then that's how I got 4 and 31. So then you can say that this is equal to the square root of 4 times the square root of 31. Now remember, anytime we take the square root of something, we always include plus or minus. So it's going to be plus or minus 2 square root 31. So knowing that the square root of negative 124 equals I times the square root of 124, or actually plus or minus I square root 124, and we know that the square root of 124 is 2 square root 31, this actually simplifies as plus or minus 2I square root of 31, right? And that's how you do that. And similarly, when you have the square root of a negative number, you just put I square root 3. We don't really know what the square root of 3 is. That's irrational. So we don't know what that is, really. That's the simplest we can put it, right? This is a very special rule, okay? When you have, so for example, the square root of negative 6 is not equal to the square root of negative 2 times the square root of negative 3, okay? What you always want to do when you take the square root of something or of a negative number, if I have the square root of negative a, I always want to say that this is equal to the square root of negative 1 times a, and that's I times a, right? Where a is any number. Where a is any number greater than 0, right? So let's do this one. 12 minus the square root of negative 3, or the square root of 12 minus the square root of negative 3 times the square root, or times 3 plus the square root of negative 4. Now, one thing that I do want to emphasize here, these two negatives are not going to cancel out because the negative is inside the square root, which means that nothing can touch it. There's nothing that can touch inside the square root. The negative is not going to go inside the square root. It can never touch it. The square root of 12, we can actually simplify it. That's equal to, so if we think about it, that's 3 times 4. And so then that equals to the square root of 3 times 2, or rather the square root of 3 times the square root of 4, which is equal to, and it's a positive number, right? Because just look at it as a positive square root of 12, right? So this is 2 square root 3. So we can simplify this term as 2 square root 3, and then we have a minus square root of negative 3 times 3 plus, and then the square root of a negative number is I, and then we have the square root of 4. So then we can go ahead and simplify the square root of 4, and that's going to give us 2 square root 3 minus, and the square root of a negative number again is I, so you have I minus I square root 3. And you can go ahead and do it this way, where you say minus the square root of negative 1 times the square root of 3, and then times 3 plus I times 2, because the square root of 4 is 2, right? So then you have 2 square root 3 minus I square root 3 times 3 plus 2I. And you can simplify this. You can say this is really, so this is A minus B times C minus D, really. So it's AC minus AD minus BC minus BD. So we have 2 square root 3 times 3, right? Plus the negative I square root 3 times 2I, or actually, hold on, it would be plus 2 square root 3 times 2I plus negative I square root 3 times 3, and then plus 2I times negative I square root 3, right? This all has to do with that rule where I said A minus B times C minus D, right? Here, A equals 2 square root 3, B equals, or it would be C plus D, actually. So B is square root negative 3, and then C equals 3, and then D equals I square root 4, which is really just 2I in reality, right? So simplifying this, we have 6 square root 3, because 2 times 3 is 6, and then times the square root of 3 is square root 3, or 6 square root 3, and then we have plus 4I square root 3, and then we have minus 3I square root 3, because 3 times the negative I square root 3, that's just negative 3I square root 3, which is this part over here, right? And then we have minus 2I squared square root 3. Now, we would say 6 square root 3, and then 4 minus 3, that's just 1, so we have plus I square root 3, and then minus 2I squared square root 3, that's just minus 2, and then we have this little I squared, so we're going to say times negative 1, right? And then square root 3. And then we have 6 square root 3 plus I square root 3 plus 2 square root 3, right? So then we look at our like terms, 6 square root 3 and 2 square root 3, we have 8 square root 3 plus I square root 3. And if it helps, you can, I mean, this can be your answer, but it can also be like, you can factor out the square root 3. You can say the square root 3 times 8 plus I, right? But in reality, this is your answer. 8 square root 3 plus I square root 3. And you always want to put it in a plus bi form, where this is a, and then this is bi, right? Where b is really just your square root 3, right? Okay. So let's solve an equation, a quadratic equation, with the quadratic formula, but this time we have an imaginary number. And we have to use the quadratic formula for this one. You can use completing the square. Actually, I'm gonna try to do both if I can. So let's see here. So let's do completing the square first, right? We're going to subtract 5 on both sides. We have x squared plus 4x equals negative 5. And then we want something, we want to add a c value on both sides. And that c value, we can use the formula c equals b over 2 quantity squared. We have b equals 4, so we have c equals 4 over 2 squared, and then we have c equals 2 squared, so c is 4, and so it's going to be x squared plus 4x plus 4 equals negative 5 plus 4. Now we can go ahead and say that this factors as x plus 2 quantity squared equals negative 1. So then we take the square root of both sides, we get x plus 2 is equal to plus or minus I, right? And then we go ahead and subtract 2 on both sides, and we get x equals negative 2 plus or minus I. So as you can see here, that's how they did it with the quadratic formula, but of course I did it with the completing the square method, and this looks a lot simpler. Unless you really don't like completing the square, you can use the quadratic formula, but the quadratic formula is a lot longer. Now, we're going to do the same exact equation, but with the quadratic formula. So if I have a, b, and c, I can say negative b plus or minus the square root of b squared minus 4ac all over 2a. So then I have b is 4, so negative 4 plus or minus the square root of the quantity 4 squared minus 4 times 1 times 5 all over 2 times 1, right? Negative 4 plus or minus square root of 16 minus 20, right? Because 4 times 5 is 20, and we have a negative here, so it's negative 20 over 2. And then we have negative 4 plus or minus the square root, and we have 16 minus 20, that's negative 4 over 2. So then we have negative 4 plus or minus, and the square root of negative 4 is I times the square root of 4 over 2. So then we have negative 4 plus or minus I, and the square root of 4 is 2, so then we have times 2 over 2. This gives us negative 4 plus or minus 2i over 2. So then we factor out the 2, we get 2 times the quantity negative 2 plus or minus I all over 2. This cancels out. And then we get that x equals negative 2 plus or minus I. That means that x equals negative 2 plus I, or x equals negative 2 minus I, right? And that's exactly what they got here. And this is another one that they did. Right? They just did the exact same thing. Negative of negative 24 plus or minus square root of 24 squared minus 4 times 37 all over 2 times 4. So then they did all of this, and the square root of negative 16 is plus or minus 4i. And then they just simplified this, right? They simplified this fraction. They said 24 over 8 plus or minus 4i over 8, which is 1/2 I, right? So then 3 plus or minus 1/2 I is the solution, and they made it so that it's the positive 3 plus 1/2 I and the negative 3 minus 1/2 I, right? So that's how this is. That's how all of this stuff is. I mean, obviously, I really did try to go as fast as I could with this. This is just review. And again, if anybody has any questions about this, you can let me know. But this was what square root, or rather what like complex numbers are about. I'm gonna do one more example here from this, right? 2 plus the square root of negative 8 over 1 plus square root of negative 2, right? So this is going to be 2 plus, and then we have the square root of negative 1 times the square root of 8 over, and then we have 1 plus, and the square root of negative 2, that's just square root of negative 1 times the square root of 2. So then this is 2 plus I square root 8 over 1 plus I square root 2. Now I can go ahead and simplify this, and the square root of 8 is really just, if you simplify it, this is the square root of 4 times 2, which is equal to the square root of 4 times the square root of 2. So this is 2 square root 2, right? And then we have 2 plus, it's going to be 2, and it's the positive square root, right? It's the positive one. So we have 2 plus 2i square root 2 over 1 plus I square root 2. Now I can go ahead and simplify this rather than taking the conjugate and stuff. There's a way to do this. You can say 2 times 1 plus I square root 2 over 1 plus I square root 2. And you can put an imaginary 1 right here. These two cancel out, so you're just going to get 2 as your answer, right? This one, square root of negative 36 over square root of negative 2 times square root of negative 9. This is just square root negative 1 times square root 36 over negative 1, square root negative 1 times square root negative 2, or actually, times the square root of 2 times the square root of negative 1 times the square root of 9, right? So then this is going to be I, and the square root of 36 is just 6, right? That's what this is. And then the square root of negative 1, let me use a different color. Okay, so this part would just be so this part would just be equal to I times I, because those two are in terms of I, and then we have the square root of 2 times the square root of 9. So square root 2 can be left as it is. And then square root of, so basically this is square root 2, and then square root 9, that can just be times 3, right? That's what the square root of 9 is 3. And so this simplifies to, and we can cross out an I here, right? And it's 6 over 3i square root 2. However, so basically this simplifies to 2 times 3, because that's what 6 is, right? And then we have over 3i square root 2. So this cancels out, and then we have 2 over I square root 2. Now, do not try to simplify this. Like, don't try to make it use the laws. Do not use the laws of exponents for this. You want to go ahead and just multiply by the conjugate, right? So remember that I said earlier, if we have 1 over a plus bi, this is going to be, we would multiply by a minus bi over a minus bi. So basically here we're going to have, so this is equal to 2 over 0 plus I square root 2. So then we have 2 over 0. So basically it's going to be multiplied by, we're going to multiply the top and the bottom by 0 minus I square root 2. So then this is going to be equal to 0 minus 2i square root 2 over, it's going to be 0 squared minus I square root 2 quantity squared. That is equal to negative 2i square root 2 over 0 minus I squared times square root 2 squared, right? So then this is equal to 2i square root 2 over 0 minus negative 1 times, and then we have square root of 2 squared. That's just 2, right? Let me go ahead and label. Right, and then the square root of negative 1 is this part, or minus negative 1, right? And then this other part is just 0 minus, right? 0 minus is this part. So then this simplifies to 2i square root 2 over 0 minus negative 2. So then it's going to be 2i square root 2 over 0 plus 2. This is 2i square root 2 over 2. So our answer is I square root 2, right? So yes, this is how it is, and I believe that's what they got here, but I really don't, I'm not 100% sure, but I really do think that that's what that's equal to. If there's a mistake that I made, please let me know, because sometimes I'm not, of course I'm not perfect, so yeah. So with that being said, guys, I believe that that is it for this section, and I really hope that helps. And so in the next section, what we're going to do is we're going to go ahead and do, which is 1.7. The next section is 1.7. We're going to go ahead and just, so it's modeling. which is a little bit harder than the other previous sections. I'll do my best, but yeah, it's a little bit tougher, but I'll do my very best with the next section. So yeah, with that being said, guys, I hope this helps, and if you have any questions, please let me know down below. And if there's anything that you want me to go over, like a problem in this section or any other previous sections that you are having questions about, let me know. If there's anything in Precalculus that you're having trouble with, let me know, and I'll try to make a video on it. But with that being said, guys, thank you so much for watching. And please like, comment, and or subscribe to my channel. And I will see you guys in the next video. Bye, guys.